Okay, so today we are going to talk about law of sines again, but we have to take a look at something that we didn't discuss last time, right? And what we didn't discuss last time is what happens if we use the law of sines to help find an angle measure, right? So let's say we've got a triangle where we know that this angle A is 25 degrees. The length of the opposite side is, say, 12 inches. And the length of little c, or it doesn't matter, little b, is, let's say, 15, right? And we want to find angle B. So, of course, we go sine of 25 degrees over 12. It's going to be equal to sine of angle B over 15. Now, when we cross multiply, and solve for sine of B, we're going to get 15 times sine of 25, which is 6.33, and then divide that by 12, and we get 0.5283. Now, obviously, this is not an angle measure, so we have to inverse sine that. So the measure of angle B is going to be equal to 31.9 degrees. Now, here's the problem, right? We did not stop right here and do what we did in the last unit and say, wait a minute, sine is positive in quadrant 1 and quadrant 2. So when we try to find the angle measure using the inverse of sine, yes, we get 31.9 degrees here, but there is also another angle whose value is 0.5283. And that angle is 148. When we do our quadrant 2 rule, we subtract the angle from 180, we get the possibility that angle B could also be 148.1 degrees. Both of these angles are potential angle measures in a triangle. There's nothing wrong with having those two angle measures in a triangle, right? So which angle are we supposed to use? And the answer to that question is we don't know, okay? Now, how can we not know? Well, to understand why angle B is allowed to be two different angle measures, we've got to go back and think about how we proved triangles congruent in geometry, right? We had our shortcut side, 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 angle, side, angle, 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 side, and side, angle, side. And what these four shortcuts told us was that if side lengths or angle measures were fixed in a certain position, then there's only one way to make a triangle like that. For example, if I had a triangle, if I gave someone 3 sticks to make a triangle, and then gave someone else the exact same stick lengths and asked them to make a triangle, then all of the 3 sides between the 2 triangles would be the same. So you've got side, side, side. What would turn out to be true is that the 2 triangles would be exactly the same. That's because if I give everyone the same 3 stick lengths, they're all going to make the same triangle, because you can only make one triangle that way. There's no other way to position these sticks to where you're going to make a different triangle. That's what those shortcuts are saying, okay? And it would be true for the other 3 shortcuts. Now, there was one that we made a big deal about, which was angle side side, that we said you could never ever use. And yes, we talked about how it's a bad word and you can't say that in school and blah, blah, blah. But the real reason why you can't do that is because if I gave someone 2 sticks now instead of 3 and said, okay, you can position those 2 sticks however you want, but this angle down here has to be 37 degrees. And 37 is arbitrary. It could be whatever you want it to be. So 42 degrees. Doesn't really matter. But if I gave someone 2 sticks and told them they had to make that angle right there, and then turned around and gave someone else the same 2 stick lengths and told them that they had to make that angle 42 degrees, something interesting could possibly happen. There's actually 2 different ways that you can make a triangle like this. And to understand how, you have to imagine making this angle a hinge, because that angle can be whatever we want it to be. So could this one, and so could this side, right? Those can be whatever we want them to be. If that's the case, then we put a hinge on that top angle that allows this side to swing either way. Well, this side could possibly swing to where the end, if this were the end, would come down past this third side, but eventually, because it's on a hinge and this length needs to be the same, is going to eventually make its way back to touching the other side, which means that now, even though this side is still the same length, you could make 2 different triangles. You might get the purple triangle, or you might get this smaller triangle here. So if we're going to fix those measurements, angle, side, side, then there's 2 different triangles you can make. So if you couple that idea with the fact that when you inverse sine, you might get 2 different angle measures, then we get to a situation where if we're given an angle and 2 sides, so that we have angle, side, side, then we have to consider the fact that the angle measures might take on a couple of different values, and we have to pay attention to that. It creates what's called an ambiguous case. Okay? Now, if this explanation doesn't make a lot of sense, then come on in and see me, and I'll be more than happy to talk to you about it a little bit more. It's kind of tough to discuss over a video like this. Okay? But bottom line is, we might be looking at a situation where in a problem like number 1 in our notes, right? We might be looking at a situation where when we find an angle, and the top of your notes has a pretty good diagram of what I just described, we might have a situation where this angle up here changes, and we can still make a triangle out of the information given if we're given angle, side, side. Okay? So, what does that mean in terms of our work here? Right? That means that in number 1 of our example, if we're given this information, angle A, the length of little c, the length of little a, and we want to find angle B and angle C, then first off, we're going to have to figure out where all of these pieces that we're given are situated. So angle A is 49 degrees. Little c is 30, and little a is 23. So we've been given angle, side, side. So we're fixing one angle measure, fixing 2 side lengths so that the angle measure is outside, and so we have angle, side, side. That means that there are 2 different ways that we can make a triangle using those 3 pieces. Okay? So, if I'm going to try to find these angles, then I have to consider the fact that they might take on a couple of different values. So to find those 2 angles, I got to look. Since I know angle A and side A, I'm going to pair those up and go sine of 49 over 23. And then because I've been given little c, I got to go find angle C first. Okay? So when you cross multiply and solve for sine of C, right, and I'm going to do this all in my calculator. We do 30 times sine of 49, then divide that by 23, and we get 0.9844. Whatever, right? It's bigger decimal. Now, obviously, that's not an angle measure, so to find the measure of angle C, I have to inverse sine. But I know that there's an angle in quadrant 1 and an angle in quadrant 2 that would have that value of 0.9844. So I'm going to have to look at both angles. So when I inverse sine this in my calculator, it will give me the angle in quadrant 1. So 79.87 degrees. To find the angle in quadrant 2, I have to say, or the measure of angle C might be 180 minus 79.87, or 100.13. So we've got two situations going on here. So we have to consider two different cases. Case one is when the measure of angle C is 79.87. If angle C is that, then to find the measure of angle B, all we have to do is take 180 minus, so just add 49 and 79.87 and subtract it from 180. And you get 51.13 degrees. Okay? So here's one possible angle for C, and here's the other one. Now, there's a second case, though, right? Because I just said here's the other one. So the other case is when the measure of angle C is 100.13 degrees. If that's the case, then we find the measure of angle B the same way. We take 180 minus, and we've got to do 49 plus 100.13. And when we do, we get 30.87. Okay, so there you go. Which one is it, right? That's always the question. And the answer is we don't know. That's why it's ambiguous. Ambiguous means we're not sure, right? So without more information, we'd have to have some more information about that triangle. Right now, we have to be satisfied with the fact that angle C could be two different angle measures, which means that angle B could be two different angle measures, okay? And again, this only happens when we're given a situation where we're fixing an angle in two sides so that we have angle side side. If this 49-degree angle were actually the measure of angle B, we'd have side angle side. And with side angle side, there are not multiple ways to make a triangle with those pieces. So we don't have to worry about there being more than one angle measure that would work. Okay? This is only if we have angle side side. So make sure you're drawing your triangle and labeling it to see if we have angle side side going on. Okay? All right, second example. And we'll walk through it a little bit quicker. So it'll take a little bit less time, hopefully. Okay? All right, so again, we've been given some information. So let's draw a triangle where angle C is 51, length B is 33, and length C is 28. And we want to find the measure of angle A and the measure of angle B. Well, since we know angle C and its opposite side, we're going to use those in our law of sines. And then we're going to have to find B first because that's the opposite side that we've been given. Right? Cross multiply and get sine of B by itself. So we get 33 times the sine of 51. And we divide that by 28. And we get 9159. And now we know that's not an angle measure, so we have to inverse that to find the measure of angle B, which could be 66.34 degrees. But we also know that there's an angle in quadrant 2 that might also work. So we subtract that from 180, and we find that angle B could also be 113.66 degrees, right? Which one is it? We don't know. And there's no way for us to know unless we have more information. Okay, so that's the measure of angle B. To find the measure of angle A, we go back to our two cases. we have to think about the fact that the measure of angle B might be 6.34, or the measure, and if so, then the measure of angle A, we're going to get by just taking 180 minus 51 minus 66, 51 plus 66.34. Which will give us 62.66 degrees for the measure of angle B. For the measure of angle A. So that's one possibility. The other one is the fact that the measure of angle B might also be 113.66. That means the measure of angle A is going to be 180 minus 51 plus 113.66. So the measure of angle A is 15.34 degrees, right? So there's one possibility, and here's the other one. Okay, again, we don't know, but all of those angle measures are potentially good angle measures in a triangle. So we don't know which one, which of the two different triangles we're supposed to be looking at. Okay? All right, hopefully that makes enough sense. If it does, then go ahead and try number 3 on your own. Stop the video, work it out, and then you can start it back up and check and see if you're right. Okay, did you get this? So the first case, the measure of angle B is 51.46 degrees, and the measure of angle C is 93.54. The second case is when the measure of angle B is 128.5 degrees and the measure of angle C is 16.46. Okay? Hopefully you did. If not, definitely find some time to come in here and let's sit down and figure out why not. Okay? Now, there are a couple of different situations that might happen. So that's one where we have two different possible angle measures, and we have to consider that that's a possibility. Okay? Now, let's take a look at what happens in the next example, right? Where we draw our triangle, so ABC, where A is 30, little a is 20, and little c is 16, right? And we want to go find the measure of angle B and C again. Well, we're going to set this up the exact same way that we did the other three. Got to find C first because that was the opposite side that was given to us. Cross multiply and get sine of C by itself. Sine of 30 times 16 is 8. 8 divided by 20 is 0.4. We know that's not an angle, so the measure of angle C is going to be inverse sine of 0.4, which is 23.58 degrees. Or it could be 180 minus that. Again, because sine is positive in quadrant 2. Now, that leads us to, again, a couple of different cases. Case 1, where the measure of angle C is 23.58. If that's the case, then the measure of angle B would be 180 minus 30 plus 23.58. Okay? And so the measure of angle B would be 126.42. Okay? So that's one case. Both angles perfectly valid. No problem. The second case, where the measure of angle C is 156.42. Then the measure of angle B is going to be 180 minus 30 plus 156.42, which will give you negative 6.42. Now, hold on a minute. You cannot have a negative angle measure in a triangle. So since angle B can't be negative 6.42, that means angle C can't be 156.42. So we cannot consider this a possibility in making a triangle. It can't happen, right? It's just not possible. So there's only one way to make a triangle with that information. Okay? That might happen too. Sometimes angle side side is a shortcut for proving two triangles congruent, but not all the time, right? Sometimes you can make two triangles out of it. In this case, you can only make one triangle out of it. Okay? But that's what's going to happen, right? Something weird's going to happen when you try to do your calculation, when you're trying to come up with your two cases. All right? All right. So a couple things here that you can work on to practice. So go ahead and work on number 5. Stop the video, start it back up, and you can check your work. Okay, and we'll do the same thing with 6, and we'll move on to the third option. All right. So again, just one of our cases should work. The other one should give us a negative angle measure. And so we should be coming up with the measure of angle B being 74.25 degrees and the measure of angle A being 22.75. Okay? All right. Good. Try 6. Again, stop the video, start it back up, and see if you get the same answer I do. All right, so there you go. Again, one of these is going to give you a negative angle measure, so we can't use it. So it turns out the measure of angle A has to be 23 degrees, and the measure of angle C has to be 33.96. Okay, if you weren't able to get to those two values, again, find some time to come in. We'll sit down and go through it. All right, there's one more situation that we need to recognize. Okay, and so we set the problem up the exact same way. Every time you want to draw a triangle, just so you can see where everything is sitting. So again, we've been given angle side side. If you were given side angle side, then this would not be a problem. You just find one angle and move on. Okay? But because we've been given angle side side, we're going to go through and find the measure of angle C first, because we've been given little c. So we go sine 30 over 7 equals the sine of c over 16. Cross multiply, get sine c by itself. You're going to get basically 8 divided by 7. So 8 divided by 7, which is 1.1429, right? And you can just go through and be a bit robotic and find the measure of angle C by inverse sining that, because that's not an angle measure. But your calculator is going to blow up. We can't. We cannot have a value bigger than 1 for sine. So if we do, we know that we cannot find an angle C for that. What that tells us is that this is not possible. This is not going to make a triangle. Right? So we're done. We don't have to worry about doing anything. We can't find an angle measure at all. But that's what it would look like if we couldn't even make a triangle. So with those 3 pieces of information, angle A being 30 degrees and those 2 side lengths being 16 and 7, we're not going to be able to make a triangle at all. Okay. All right. Take a look at number 8. Go ahead and set it up, work it out, and see if you can't discover that you can't make a triangle here either. Okay, stop the video, start it back up, and see if you're on the right track. Okay, there you go. I end up with sine of A equaling 1.996. And again, it's bigger than 1. So we cannot find angle A, which means we're not going to make a triangle out of this. All right? All right. So we can extend this to helping us find a side length, right? And so let's take a look at that particular situation. Okay, and I know I'm going to need more space for this, so we'll create some more space here. All right. But we're going to set this up. Again, we don't know that we're in a right triangle. So we've got to draw a triangle here, ABC, where A is 28 degrees, little c is 34, and little a is 32. And we want to find little b, the side length that would be b. And in order to find that side length, we're going to have to find the measure of angle b. That's what we're going to have to use in our law of sines. We would use, to find b, sine of 28 over 32 equals sine of b over its opposite side length. So we can't be missing both of those. So our task has to be to find the measure of angle b. Well, in order to do that, we're going to have to set this up and try to find the measure of angle c first. Now be careful, we've been given angle side side. So there may be two different possibilities here for angle c. So we set up our law of sines, cross multiply, and let's see, what are we going to get? So we get 0.4988. Now we inverse sine that because we know that's not going to give us an angle measure. And so we get 29.92. So it does give us an angle measure here. But we have to remember that the measure of angle C could also be 180 minus that, because it could be an angle in quadrant 2, which is 150.08. Okay? So since there's two possibilities for angle C, there's going to be two possibilities for angle B. So, case 1, where angle C is 29.92. That means the measure of angle B will be 180 minus 28 plus 29.92. We get 122.08. Now, case 2 is when angle C is 150.08. And so the measure of angle B would have to be 180 minus 28 plus 150.08. Gives us 1.92 degrees. So it's another possibility for angle B. Now, if that's the case, if angle B might be two angle measures, and it could be because both of those angle measures are perfectly valid, that means side B is going to have two possible values, two possible lengths. And so we're going to have to set up our law of sines with both possibilities. So for the first case, we're going to use angle A. So we're going to do sine of 28 over 32 would be equal to, now we've got to use all the B stuff. Angle B in case 1 is 122.08, so we're going to take the sine of that over little b. And then we cross multiply and just get b by itself. So we multiply 32 times sine of 122.08 and then divide that by the sine of 28. And so little b might be 57.75. Okay, in the first case. Case 2, we're going to do the same thing, only we've got to flip over to the other angle and now make this the sine of 1.92 over little b. Cross multiply, get b by itself. So now we got to take 32 times the sine and divide it by the sine of 1.92 and divide it by the sine of 28. And so here, the side length b might be 2.29. And so we've got to go find both possibilities. So it's one more step, 2 cases we have to check out. So, all right. All right. 2 more examples that I'll let you work on. I'll show you what I come up with for the solution. And hopefully you're working these just fine and you can get into the homework. All right, so for the second 9, did your 2 lengths for side C come out to be 62.20 and 1.01? Right? A little bit weird that angle B did end up being a decimal, 0.29 degrees. We keep making a big deal about how those decimals are not usually angle measures, but in that one it was. So if you got that, then you're fine. And hopefully you got those 2 side lengths for C. Okay? One more example for you to try, and I'll show you the answers. So stop the video, try to work it out. All right, and so the last one here. I know that it said determine B, but we already had B. So my guess is we were supposed to go find C. You can find the work there, the measure of angle A. Could be 27.96 or 152.04, which means the measure of angle C could be 129.04 or 4.96, which leads us to find the the length of side C being either 49.7 or 5.53. So hopefully you got those same things. If not, and you're not sure why, then again, find some time, come in, sit down, and we'll go through it. Okay, otherwise, homework's out in Canvas. Have that done by next time.